So in this example right here, we're going to be discussing the no solution case. So let's just go ahead and solve it. We're going to do it through addition and elimination and not through substitution, but if you would rather do that, that's perfectly fine. The first thing that comes up for me is I would either pick the x or the y variable. I think they're both relatively easy. Notice that if you pick the x here, then you can multiply by -3 to get that one, or the -2 to group it with the second one on the bottom. But the y values are also very nice because these, the +4 and the -4, are already lined up the way they should be. So let's go ahead and do that one, where we take the first equation and line it up with the second one, the last one. So can we see that these ones will cancel right away, the y's? Before we go and solve that one though, let's write the other pair, which is going to be this one and any of the other two. Since the top one is positive and the bottom one is negative, I'm going to pick those two. So 3x plus 4y plus 5z is equal to 8x minus 2y plus 3z is equal to -6. So let's go ahead and solve this one. Since it's already in the form that we want, where the constants are the same but different signs, we can go ahead and just add straight. These cancel. You're left with 5x. These two give you plus 11z, 16. And now the second one, the second pair that we have, the y's aren't the same yet, right? The constants in the front. So we need to multiply the second one by 2. So let's go ahead and write that out. And so we get 2x minus 4y plus 6z is equal to -12. And let's go ahead and rewrite the equation. So now we can add straight down and you will see that the y's cancel again. So 5x plus 11z is equal to -4. So again, once we have this part done, we have a 2 system. But let's go ahead and write the equation right underneath. And I think you'll see something very unique about this problem. Can we see that the numbers in front of the x are the same and the numbers in front of the z are the same? So if we were to do the addition problem, they would both cancel. So let's go ahead and do that. And how I'm going to do that is just by switching the signs. And what this does is it's multiplying both sides by -1. If I add straight down, these cancel, so the left side is 0, but the right side is -20. So this right here is a false statement. It's always false. And when we ask the same question that we did when we did the 2 system, where do these, instead of lines, they're going to be planes, touch? Now the answer is always false. So can we see that this is a no solution problem? What's really nice about the no solution example is anytime you get a false statement, this entire system automatically has no solution. So if you were to, let's say, group these two and these two instead, and you get a false statement at the very beginning, right here, automatically no solution. There's nothing else you can do. Okay, so let's do the last example. And in this example, we're going to see a case where we have infinitely many solutions. And since we did addition and elimination in the previous example, let's do this one by substitution. So what I'm going to do, notice that there's a few things you can do. You can pick X here, you can pick Z, or you can pick Z here. I'm going to pick Z in the second one for a very particular reason, and we'll see that later on. But it doesn't matter which of the 3 you choose. So for that second equation, let's write it out. and let's solve for z. So what I'm going to do is I'm going to add 4y to both sides and subtract 3x to both sides. So you can see that these cancel now, and all you're left with is z on the left. And if I just write this in that order, you'll get the right-hand side. So the 4 plus 4y minus 3x. So in substitution, what we want to do is we want to take this variable and plug into the other two. So if I write out the 6x minus 8y plus 2, plugging in for z, let's see what happens. The z value is the 4 plus 4y minus 3x. And doing this distribution here, we get 6x minus 8y plus 8 plus 8y minus 6x is 8. Now, notice that we have like terms. This one here, as well as this one over here. And they're the same number but opposite signs, so they all cancel. And what we get left with is 8 on the left and 8 on the right. Can we see that this is a true statement and it's always true? The dangers of an infinitely many solutions problem is, unlike the no solutions case, you have to do the second part. You cannot conclude that you have infinitely many solutions just from one case. And the reason for that, I could draw this out, is if you have a plane and another plane which lie on top of each other, it is possible for you to have a third plane which is nowhere near, right? They're floating above each other. So just because these two planes touches, which is this green and this orange one, doesn't necessarily imply that this black plane is going to be on top of it or touch it at all. So we need to solve this second part, which is going to be plugging in this z value into the first equation. So let's go ahead and draw that. X plus 2y plus z equals 4. And this is going to be 4 plus 4y minus 3x. So these two add together, and these two add together to give you minus 2x plus 6y. You can leave the plus 4 there. It's equal to 4. Subtracting 4 to both sides gives us negative 2x plus 6y is equal to 0. Now, what this tells you is that line 1, which is this one, and this one, which is line 2, they intersect at this line. So if these two planes are on top of each other and this third equation intersects both of these planes on a line, they have infinitely many solutions. Because we don't have a second equation here, right, this 2 by 2 equation, or sorry, 2 variable equation, we cannot solve it any further. You just have to understand that 2 planes overlapping and the third plane intersecting them at a line implies that we have infinitely many solutions. And what that looks like visually So this is what it looks like, where we have the orange one being line 1, or sorry, plane 1. In this case, I'm sorry, plane 2 and 3. and then this black one is going to be plane 1. And what it's doing is it's intersecting at this line. Right there. So hence, infinitely many solutions, they touch on that line. So lastly, we write out the solutions as these planes touch at infinitely many. I guess we should write it out instead. Infinitely many points. So there are infinitely many solutions.